Hi, in this video we're going to change the subject of the formula involving higher powers of x like x cubed, x to the 4, etc. and fractions and brackets as well. So to make x the subject of the formula means to get x on its own on one side of the equation, right? So we need to gradually undo the things around x to get x on its own. It's like unpeeling an onion, if you like, where x is in the centre. Now let's think what's happening to x. It's been cubed, then it's been subtracted from b, then that whole thing is times by a, and then it's being divided by c. Now we undo the last thing that happened to x, which was this divide by c. So we're going to multiply both sides by c to undo the divide by c. So on the left-hand side, we just get cy rather than yc because we put them in alphabetical order. And the times c on the right-hand side cancels out this over c, leaving that numerator there like this. Now, in previous videos, I've said when you have a bracket like this, there's two strategies. You can either divide by the thing on front of the bracket. So this b minus x cubed is being multiplied by a. So you can undo the times by a by dividing both sides by a. Or, and I prefer this way, you expand out the bracket. So let's do that. We do the a times the b, which is ab, and we do the a times the minus x cubed, which is minus ax cubed. The reason I like to expand out the bracket is because you tend to have less risk of having like fractions within fractions at the end. So it ends up generally with a tidy expression if you expand out the bracket. Now, okay, what do we do next? Now, this x is in a term that's being subtracted from AB. And remember, in previous videos, I've said, if the subject is in a term that's been subtracted from something, you can use something called the swapsy trick to save a bit of time. So the swapsy trick is this. And it's actually quite simple. Let's suppose you had 10 minus 7 is equal to 3. How could you swap the numbers in that subtraction to still make it true? Well, you could have 10 minus 3 equals 7, couldn't you? So it seems to be that you can swap the thing you're subtracting and the result of that subtraction. And you can do the same in this equation. So you can swap the thing you're subtracting and the result of that subtraction. So you're going to swap these two things here. And if we do that, we're left with ax cubed equals ab minus cy. And that's nice because now the subject x is in a term that's not being subtracted from something. It's much more now free. Okay, right, let's see what's happening to x. It's being cubed and then it's being multiplied by a. So we need to undo the times by a, the last thing, which is to divide by a. So the left-hand side now is just x cubed and the right-hand side is ab minus cy all over a. We divide it by a. And now the x has been cubed, so you undo the cubed by cube rooting. So the cube root both sides. And remember, we write a cube root as a root symbol with a little 3 on the top left. So we do the same to the right-hand side. Now on the left-hand side, the cube root cancels the cubed, just leaving x. And on the right-hand side, we've got to cube root the whole thing, making sure that root goes over the whole fraction. And we have ab minus cy over a here. And that is the final answer because we've managed to get x on its own on one side of the equation.